Hello students, and welcome back to Chapter 16, the Respiratory System. This is Part 2. The breathing mechanism is controlled mainly by Boyle's law. This is a law in physics that says that as pressure of a gas in a closed container is inversely proportional to the volume of the container. So as the pressure decreases, volume increases. Or you could say it the other way, as space increases or volume, then pressure decreases or falls. Gas flows from an area of higher to lower pressures. So as that space increases, the pressure decreases, and the gases will flow from an area of higher pressure to an area of lower pressure. Gas pressure is measured relative to atmospheric pressure, so 760 millimeters of mercury is our atmospheric pressure. Now we have two syringes here. As we pull the plunger out, we're increasing that space, right? Well, that's also increasing the volume, and remember, as volume increases, pressure is going to decrease. Which way is the air going to flow? It's going to flow in the direction where the pressure is decreasing, okay, is lesser. So as this volume increases in this cylinder, as we pull the plunger out, the volume will increase, the amount of space. As that increases, it's going to drop the atmospheric pressure. As the atmospheric pressure drops, air rushes in. So moving the plunger of the syringe causes the air to move in this case. In B, we see we're pushing the plunger in. So we're decreasing that space, decreasing the volume, so the pressure or the air moving is going to be inverse, or the pressure is going to be inverse, which means just the opposite. As the space becomes smaller, the volume becomes smaller, the pressure will increase, and the air will rush out or be pushed out. So air moves in or out of the lungs according to which, or much of the same way. It depends on atmospheric pressure. With the breathing mechanism, inhaling and exhaling is called ventilation, and inspiration is another word we use for inhaling. It's just like pulling out the plunger. When we increase the space in our lungs, as the diaphragm and these intercostal muscles, the thoracic muscles here, increase this space, it's going to increase the volume and decrease the pressure, and the air is going to rush in. So intra-alveolar pressure decreases to 758 millimeters of mercury as the thoracic cavity enlarges. And so we were at 760, now we're decreased to 758, and atmospheric pressure forces the air into the passageways. So as this thoracic cavity enlarges, it's going to pull the air in. Okay, so atmospheric pressure is 760. So we said it moves from a higher pressure to a sort of like diffusion, as we talked about before, a movement of molecules from an area of higher concentration to an area of lower concentration. But now we're talking about atmospheric pressure. So 760 millimeters per mercury of mercury, and then the intra-alveolar pressure reduced to 758 by enlarging the thoracic cavities with the action of these muscles, is going to pull that air into that passageway and into our lungs. Now, while this is happening, let me say something about the chemical we produce called surfactant. Now these alveolus, alveoli, have liquid on the surface of them, and most of our interstitial fluids is made up of water. And let me talk just for a second about the chemical makeup of water. It is 2 hydrogens and 1 oxygen, and hydrogens have these negative units that spin around on the outside of the atom, this hydrogen atom, as